Previously, we look at what are the units and what are the basic units we have. So we learned that we have 7 basic units. The quantities are for mass, length, time, temperature, current, amount of substance, and luminous intensity. Right. So the corresponding units are kilogram, the SI units for the length it is meters, time seconds, temperature Kelvin, capital K Kelvin, current amperes, amount of substance mole, and luminous intensity candela. So how can we use these basic physical quantities to derive units? So let's take an example of velocity, and we should know the equation for the velocity. So if it is velocity, then it is displacement divided by time. So we will go over what displacement are, but for the time being, displacement is a length measurement, right? So if I want to know the unit of the velocity, then it is the unit of the displacement divided by unit of the time. Right? Whatever the equation we have, we will use that equation and we will find the units. So I mentioned that unit of the displacement is unit of the length, which is meters, and unit of time is seconds. So we can write it as meters per second, or there is a different way of writing it, which is meters second minus 1 as well, right? So this is a negative power index. So either you can write it like this, or you can write it like this. Then if we go ahead and if we do for force, force is given by mass times the acceleration. So unfortunately, in order to know the acceleration, we do not know what an acceleration is. So we will go ahead and we will understand what an acceleration is. So acceleration has a equation which is velocity divided by time. So we looked at what is the unit of a velocity, which is meters per second. So I can say, or I can write it again. So we can say unit of acceleration is equal to unit of velocity divided by unit of time. So the unit of velocity is meters per second, time is second, so it is meters per second squared, or you can write it as meter second minus 2. Similarly, we can go for, now that we know the acceleration's unit, which is this, we can find that of the force. So unit of force is given by unit of mass. Since it is a multiplication, we are going to multiply the corresponding units times unit of the acceleration. So the unit of the mass is kilogram. Unit of the acceleration is meters second minus 2, or meters per second squared. So it is going to be kilogram meter second minus 2, or kilogram meters per second squared, right? So similarly, we can find any units or any unit of any equation or a quantity, as long as we know the equation which represents that quantity, right? So now we can go ahead and do some real problems, like so there is an equation which is given by F equals to G capital M simple M over R squared. So this is the equation for gravitational force, right? So write it as gravitational force. and that equation is this. So this equation is proved by Newton's. So we call it Newton's gravitational law as well. We won't be studying this law now, but understand. So this is force. This and this mass, and that's your radius, right? So this capital G is called universal gravitational constant. It is a constant. It has a particular value. It is a constant, and the name is universal gravitational constant. So the task we have is to find the unit of the universal gravitational constant, right? So the question is, find the unit of G. So we have this equation. So this equation is given to us. So in order to find the unit of the equation, we want to find what G is. So we can rearrange this equation. So this equation is G capital M simple M over R squared. So if I rearrange this equation such that G is the subject of the equation, I'm going to have FR squared over capital M simple M. Now that I know the equation for G, I can use that and find unit of G is equals to unit of force multiplied by unit of R squared divided by the unit of capital M unit of simple M, right? So we have few things that are not in orthodox way. So first thing is the unit of R squared. What is the unit of R squared? So what is R squared? So R squared is basically R times R. So what is the unit of R squared? It is going to be unit of R multiplied by unit of R. So radius is a measure of length, right? So radius is going to measure the length. So unit of R is basically the unit of length, which is meters, and it is meters, so it is meter squared. So at this point, you should understand, as long as you have a power, it is whatever the corresponding unit that you measure it with and the corresponding power, right? So unit of the force we know, which is kilogram meters per second squared. So kilogram meters per second squared times unit of R squared is meter squared divided by unit of mass is kilogram. We have another unit of mass, which is also kilogram. So this is going to be meter cube divided by second squared kilogram. So either you can write it as meter cube second minus 2 kilogram minus 1, or you can keep it as meter cube per second squared kilogram, right?